Welcome everyone on the experiment on dissolution and precipitation, and in particular we are looking at the thermodynamics of calcium hydroxide dissolution. In the first step we are assembling all the chemicals which we need, all the instruments which we need, and all the vials which we need, and supporting materials like pipettes and cylinders and filters. Okay, so we put them all together, equally here the balance. And once we've put all together, the acids here, we have actually the fume cabinet, because we work with concentrated acids in the fume cabinet. And once we've everything together, we start to prepare the solution. So here you see Fatimah, who presents this experiment. She will weigh out calcium hydroxide. We need just more than 2 grams, okay, so that our samples are in excess. You see, she always very carefully makes a tara, closes the windows, and she weighs out already 4 samples, because we will do 4 different experiments at 4 different temperatures. Now you see here how she prepares the 0.1 molar HCl solution. So for that she uses concentrated HCl, and that's the reason why she does all the work in the fume cabinet. You see the screen is between her eyes and actually the solution, so it's a little bit experience, a little exercise to feel comfortable. Any movement, always do them very comfortable. But you feel comfortable. Here she adjusts the volume she needs. Okay, she needs 1 milliliter in that case, and you see she decanted the HCl into a small glass vessel, so it doesn't go into the original solution. She takes it from there, takes up 1 milliliter, and then puts it into the vessel which it actually uses during the experiment. Remember, always we put in first water and then the acid, and you see here how she very carefully pushes down and releases the bottle. Okay, so that's the first part which she did. So the first 250 mils, and now she prepares the second 250 mils. Okay, so make very sure that you are the water is at 250. Okay, so the sinus, and look at the meniscus. Okay, so she adds now the water, and then afterwards she will add the acid. Always test before you do any experiment so that your movements work fine, so not that you feel restricted. Okay, so once you then work with really the acids, you want to make sure that you have good movements. Once everything is prepared, then you don't forget to label it. Okay, so you label it. Okay, that is your 1 molar HCl, and also the date when you do it. Potentially also write down your names. Now she does the calibration of the pH meter. Okay, the pH meter, she uses 4 different calibration solutions with different concentrations of H+. She measures the potential. Okay, so you see this small handheld potentiometer measures the potential, and then for different pH standards she has different potentials, and this calibration curve she will use that. Now in step 2 we are setting up the experiment. For that we use the magnet stir. Okay, we put the vessel on it, then we add the pH electrode, fix it, we take the thermometer, the thermometer, so that we know the temperature. Now in the step 3 we are conducting the experiment. So here we see the setup which we just prepared, and the first thing is that we add the water where we dissolve the calcium hydroxide. Okay, so we make this experiment, first experiment, at 25 degrees. We add the water, we add then the magnet who stirs our solution as we put in the calcium hydroxide. Now we put the calcium hydroxide, which we weighed out before, to the solution and stir it. Okay, the amount of calcium hydroxide doesn't have to be exact known, it just has to be more than 2 grams, so that the calcium hydroxide is really in excess. Okay, And then we start to heat up. The aim is to heat up to 25 degrees. So it's difficult to get exactly 25 degrees, so therefore we measure the temperature which is in the solution, so we know exactly the temperature, and we stir it. Okay, and so we have to wait a little bit till it goes up to 25 degrees or what's about, and then we measure the temperature. We measure the pH. Okay, using the pH electrode, and we wait a little bit, okay, a couple of minutes, and once then the dissolution is in equilibrium, then we take with a syringe approximately 10 milliliter of solution out. Okay, so very, very carefully, and then we use a filter, so we add the filter to the syringe, and slowly, don't push too much, the solution into this Erlen vial. Okay, we repeat that 3 times because we want to get 3 different readings. And now in the next step we are determining the concentration of OH minuses in our filtrate. Okay, in the first step we pipette 10 mils of the filtrate into a new beaker. Okay, so very careful. So now we have to be very exact. We do that for all of our 3 repeats. We always carefully pipette 10 mils into the beaker, and now we add another 20 mils of water into our beaker. Okay, and again we do that for all of the 3 repeats. Okay. And once that's done, then we can add the indicator. Okay, it's an indicator which has to change the color if the protons are in excess. We just add a few drops. Doesn't matter how much it is exactly. Okay, just a couple of drops. Do it for all of the 3 beakers. And in the next step, we take the magnet. Okay, take a magnet and add them to the beaker. So we need to be able to stir it. Okay, through different magnets, and hit one after the other. Okay, and once that's done, then we discard of the pipette in the waste, and then we set up our new titration setup. We assemble it. Okay, so we use a pyrite this time to add the acid. Remembering the video which you saw on the acid base, there we added the acids and the bases with a pipette. In this experiment we use a purette. Purette gets prepared, so you see here, so it closes the vial below. Okay, that's very important, the vial is closed, and then Fatimah carefully adds the acid. Okay, she adds it above the 0 mark. If needed, you can flush your purette a couple of times, and once it's ready, then she lets the acid out that it reaches the 0 mark. Okay, very, very careful. Get it here to the 0 mark. Okay. Okay, check if the meniscus forms at the lower part of the meniscus is at 0. Very, very careful. Now it's course important that we are careful, because we need to know exactly how much of acid we add to our filter. So now she prepares everything that you can put the filtrate and the magnet stirrer under the burette. So she pushes it back now, brings over the magnetic stirrer, and now we make the first titration. Okay, so the burette is placed carefully over the filtrate. Okay, it needs all a little bit of adjustment, manual skills, but once that's up and running, then you start for each of the repeats, you do the titration, and that means you just add the acid, okay, the 0.1 mole HCl, and you add that very, very carefully, so step by step, because you want to stop the addition of the acid as soon as the color changes. Yep, it happened already. Okay, so the blue turned into the yellow. You look where now the meniscus is, and you write down, note how much of acid you used. And you do that now 3 times. Okay, remember, we collected 3 different filtrates because we want to get at least 3 repeats. It's important so that we can calculate the average and the standard deviation, okay, so that we get an idea of the error of our determinations. Again, very, very slowly, okay, and be ready for when the color changes, okay, switched off, so there's no acid added anymore, and now carefully note how much acid you added. So that has been repeat number 2, and now the last repeat, so repeat number 3. Again, you see it's very nicely blue. Sure that there's a nice vortex forming so that the solutions are well mixed, okay, the filtrate and the acid which you add, and then you just repeat it again and again. Look carefully and slowly that you exactly get the point when the color changes. Again, you note carefully the lab note, and now you have 3 repeats, and you can now determine the average plus the standard deviation from this. Okay, so now that concludes. And now in the last step, step 5, we repeat exactly what we did at 25 degrees. We repeat that at 4 different temperatures. Between 25, you choose between 25 and roughly 80. Don't go much above 80, because then otherwise, or 90, because otherwise when the water starts to bubble, then it gets a little bit messy. It's also difficult to make take the samples and so on. So don't go above 80, but otherwise you just repeat exactly the same. Okay, so at 40 degrees, roughly 60, so you always heat up, use the thermometer to get the exact measurements of the temperature, and as I said, always add the calcium hydroxide, wait a couple of minutes till it's at equilibrium of this solution, then you take sample out and filtrate 10